Okay, so this is part 2. We're just continuing from where we left off from last time. So as was stated, this is a square. All sides is 6.9. Rather than add in all the sides, since there's 4 the same, you could just do 4 times 6.9. I'm just going to put inches because we need to label. So then you do 4 times 6.9, and you would get 27.6 inches as your perimeter. For area, we know it's s squared. We already have the side, 6.9, and we square it. So you plug that into your calculators, and then you get 47.61 square inch. So you can put inches square, or you could write as square inch. So I'm going to write 47.61 inches square. Don't forget the labels, because you just give me a number, then I'm going to take points off for no labels. They give you a label, use it. And make sure when it's adding up all the sides, you keep the same label, whether it's inches, feet, whatever it is. When you square, it's going to be square inch, square foot, square feet, square centimeters, whatever the case may be. All right, another example. So this is a trapezoid. If you remember the formula for area for a trapezoid, and also for perimeter, we just adding up the sides. So let's do the perimeter first. They give us all the information that we need. Perimeter is just the outer part. So I'm going to outline the outer part, because I've seen this before where students add up the outer part and then they end up adding the height. This is inside. This has nothing to do with the outside. So the one that I highlighted in green is the outer part. That is what you are going to add. So perimeter, so the S1 was 6.21, and then we have 5.95 plus 4 and plus 8.7. So then when we add that all together, and using the calculator, I would get 24.86 milliliter. I mean milliliter. That's for liquids. Millimeter. And then for area of a trapezoid, remember, if you go back to that chart, it was half times height times the sum of the two bases. So you just plug in the information that you have. So the height is 5.6. And the base, you got 4 plus 8.7. And then you just simplify. So half of 5.6 is 2.8. And then when you add the two numbers, this one will be 12.7. And then you multiply those two. That should give you an area of 35.56 millimeter square. So put that over here. Okay. So again, it's you memorizing the formulas. Know what's perimeter? Perimeter is outside. Anything that's outside of the shape. Well, I shouldn't say outside the shape. What creates the shape, the outer part, is what you add up. Height is not part of that. Okay, so we have a triangle. Perimeter, same thing. It's the outer part. So I'm just going to highlight it again. So that way you are well aware that you are adding the outer part for the perimeter. I'm going to use green for that. P equals ABC. They already have the measurements here. So 6.4 plus 8.84 plus 9.7. And then when you add those all up together, you should get 24.58, and the label is inches. For the area of a triangle, I'm going to use another color for that. I use blue. So for the area for a triangle is half base times height. Sometimes the half gets ignored. Don't ignore it. For a triangle, there's a half in there. And they have the base. This is the base, the bottom part, C. So it's 9.7 times the height, which they gave you as 5.4. So now you're going to multiply all the numbers. And then you get 26.19 square inches. Okay, not too bad. So for your homework or any test or stuff like that, if they ask you for both the perimeter and area, make sure you show both, not just one or the other. Alright, so this, we have a shape of, since there's S and S, this is a square. Well, actually it's not a square, it's a parallelogram, but it would be a rhombus because the sides will be all the same and it's tilted. In this case, we're looking for the perimeter, so that means we're just adding up all the sides. And again, I'm going to do that highlighting because just so that way you do not add the height when it comes to the perimeter. I know I'm going to see that, and I don't want to see that. So P equals, and since all the sides are the same, I'm just going to multiply it by 4. Why waste my time adding 7 4 times when I can multiply it? So it'll be 28 yards. And then for the area, since this is a parallelogram, even though it's the same sides, and we have the height, so it would be base times height. So we have the base, which is 7, and then the height, 6.49. Multiply those two, 6.49, gives us 45.43 square yards. Put that. You could also put it like this, square yards. That's the SQ and then whatever the label was. Alright. Now we're doing a circle. Circle. We're doing the circumference. Circumference is the same as perimeter. It's the distance around the circle. So for circumference, they gave us, we don't know the radius is, but we know what the diameter is. Diameter is half the radius. Radius is half the diameter. So I would put D equals, D over 2 equals R. Let me make that better. I didn't like that. Alright, so that means you just basically divided by 2. This will be 7 centimeters. So now you can find the circumference. So if you didn't find the radius, you'd still have to use the radius because you need it for the area. You could have either used pi d, or you could have used, put a big or here, or you could have used 2 pi r. And that 2r replaces the d because you need two radii to make a diameter. So let's say you used the one with d, it would be 14. So you would have 14 pi. Leave it in terms of pi. Most of you might want to convert it using 3.14, 15s, whatever. Just leave it in terms of pi. Or if you use the 2 pi r, you would have 2 pi times 7, and of course you would get the same thing, 14 pi centimeters. So we put that here. And then for the area, I'll use another color. I'll use green. Area of a circle is pi r squared. Don't get that confused. Circumference 2 pi r, area pi r squared. So you already found the area, the radius. Now we're looking for the area. We have a 7, square it. So it'll be 49 pi centimeters square. Oops, forgot the pi. Can't forget about the pi. So got pi centimeters square. Okay. So we have a triangle. So again, this is just using our formulas to find the area and the perimeter. So I'm going to go through these quickly. If there's any time that you miss something, you can always pause and then go back. Go back to check and see what's going on. Sorry for the background noises. There's landscaping going on, and of course a truck passing by. So we got 22.99 yards and an area. This is a triangle, so it's half base times height. So half, the base is A, which is 8.7, and the height is B, which is 4.5. So then you got half times 8.7 times 4.5 gives you 19.575 yards, square yards. Alright, moving on to the next one. So again, this is all just review. So this parallelogram, we add in all the sides, so A and C. So we're looking at A and C. Since A is the same as this and C as this, basically you would just do, it'd be length and width, so 2L plus 2W. So we'll do P equals the 2 lengths, which is C, which is 9.6, and then the 2 widths, A, which is 6.08. So then it'd be 2 times 9.6, which gives you 19.2, plus 2 times 6.08, which is 12.16. You add those two, and you get 31.36 inches. And then for the area, it's base times height, since it's a parallelogram. So base is the C, 9.6, and the height, 5.5, not A. This A is not the height. Height means vertical. So please be careful, because it's bound to happen when someone's going to replace the height, the side of the parallelogram, as the height. No. Okay, so let's continue with this and find our area, which is 52.8. 52.8 square inches. Okay, so let me see. Okay, so if you get the hang of it, you could move on to the next section. If you still need more practice, want to see more review, then just stick around. So perimeter, we're doing the outside. I'm going to highlight it, the outer portion of this trapezoid. And I'm going to use green, so we know that we're dealing with this. So we add in B1, B2, S1, S2. So 4.9 plus 10 plus 5.83 plus 4.84. So let's all add that up. 10, 5.83 plus 4.84 gives us 25.57. And our label is inches, feet. Our area, which I'll use another color, I'll use purple for that, since we're dealing with trapezoid, it's half times height times the two bases together. They give us all the information. We've got the height and the bases. We just add 4.9 plus 10. So half of 4.6, 2.3. And then we add this. This would be 14.9. And multiply it. 14.9 gives us 34.27. So the area is 34.27 square feet. Alright, so now that you got the hang of using perimeter and area and distinguish between the two when it comes to finding both for shape, we're going to combine. We're going to be doing with areas where we combine different odd shapes. So mentioned in the beginning where you may have a room that may look funky, like you see over here. I mean, it would be a very weird room shape, but it happens. There are rooms that have weird shapes, and you need to find the area. So in order to do that, let me go and select. In order to do that, they give you all the information. Look at how many shapes you see in this diagram. You can see that there's three. We have a triangle, we have a rectangle, and we have a parallelogram. Now, if you know the areas of the parallelogram, the area of a parallelogram, rectangle, and triangle, you could individually find the area of each to get you the total. So, in this situation, I would label. So the first one was the triangle. I labeled it A. So for A, I used the area formula for triangle and plugged in all the information that was given. So I had my base. I know my base is 9. Like, how did you find out that this was 9? I looked at this. This is 9. That means this is also equal. This would be 9. This is equal to this for the rectangle. The two lengths are the same, so this is 9. So therefore, the base for this triangle is 9. So just look at all the information they give you, connect it based on what you know in order to find what you need to find. So I did all of that, and I found my area for the triangle. Now I labeled the rectangle B in orange. Actually, yeah, it was orange. I'm using the pink. So I found the area for the rectangle, which is base times height. Like I said, I knew that this is 9, so the parallelogram part, top part also is 9, so that means this is 9, 9. And then I know what the width is, the height, which is 3. Multiplied it, got 27. And then the last one, which I label C for the parallelogram, I used the parallelogram formula, base times height, and then found that this is 9. But now, the height. You don't know what the height is, but the thing is, they gave you the overall length of this shape. So we already have the height of the triangle, which is 7. You have this piece, which is 3. So then you have 7 and 3. That gives you 10. So all you had to do was subtract 10 from 16 to give you 6, and that gave you the height. So like I said, use all the information they gave you in order to find what you're looking for. Alright, so once I found the area, I added them all up. Added the triangle, the rectangle, and the parallelogram to give me the total area of this funky shape. So the next few examples, we're going to be doing odd shapes and finding the area of it. Alright, so this is the shape that we have. you need to break it into familiar shapes that you are familiar shapes in order to find the area of each. So I did that, and then I label it A, B, C, D, E, and then find the area of each. So for the first one was A, which is a rectangle. Use that and found the area. For B, it's also a rectangle. Base times height, or length times width, same thing. Found the area, 27. Label the triangle C. Found the area of that. Half base times height. Found the 27. Found the area of D, which is a square. Because notice how they have 6 for this one, but notice how from here to here, this is 6. 6 and 6. I could have used S squared, side square. But in this case, I could use base times height. Same thing, because I'm still going to multiply to each other, and got 36. And then for the last one, E is a triangle. Use the triangle formula, and then found 9. Once I found the 5 areas, let me put it down here. I added them all up and got the total area, which was 153. So you got a shape like this. Break it down into shapes that you are familiar with. Find each area, put them all together, and then you got the total area. You can never fail with that. Okay. So now, since you know about areas, we're going to be finding the area of irregular and shaded figures. So, well, we already did irregular shapes, but for shaded figures is another thing. For irregular and shaded figures are made up of more than one polygon. Polygons are different shapes like triangles, squares, rectangles, and so forth. To find an area of irregular figures, this is basically the step. This is what we just did for the previous 2 examples. Find the area of the individual polygon. So break it into familiar shapes that you know, and then add the individual areas to find the total area of the regular figures. So break it down to the shapes you know, find the area of each, and then add them all together to get the total area. To find the area of shaded figures, find the area of each individual polygon, and then subtract the smaller, non-shaded, from the bigger, the larger shaded figure. So we're going to do examples based on shaded figures. So it's almost like if you had 2 shapes and you want to pull one shape out of the bigger shape, what would be left behind? It's like if you had a box that was not covering, that was surrounding a ball. You pull out that ball and you have that empty shape of the ball, which it created a circle. You want to know what was left over. So that's what we're going to be doing. So we have this figure. So let me break this down. So we have 2 shapes. We have a square and then we have a circle. So for the first one, I'm going to write, I need to find the area of the square. I'm going to label it SAS. And we know that square is side square. So now, do we have the side? You're like, we don't have the side. How am I going to do this? Look at the diameter. The diameter is in the middle of the circle. It starts from the beginning of the circle to the other side. It is the same as the top and the bottom of this square. And we know it's a square because if you did a diameter going vertically, it would also be 12. That means this will be 12. So then our side is 12. And our area is 144 centimeters squared. Now, we're looking for the circle. And I'm going to label it C for circle. Get into the habit of doing that, because so that way you know that this represents one of the shape and the other shape. So this one is area pi r squared. You have the diameter. Can we find the radius? Yeah. You divide the diameter into half by half, and then you get 6. So you got pi 6 square, and then this would be 36 pi centimeter square. Now, we're not adding because we're trying to find the area of the shaded region, which is the blue part. So we're going to grab the bigger and then subtract. I'm going to put AT for total. Actually, you know what? I'm going to put it as, let me get this out. Undo again. So I'm going to put A, what color was I using? I used blue. So I'm going to put ASR, that's shaded region, and I'm going to subtract. So it'll be 36 pi minus, oops, did I do that right? Nope, sorry, I mixed that up. The bigger is 144. Gotta pay attention. So 144 pi, 144 minus 36 pi centimeters square. And that's it. That's your answer. The area of the shaded region. I took the bigger, this was the big one, minus the small. Do not combine this, because we already learned in the previous lesson that when you combine, if you're going to combine terms, they have to be like terms. This is not like terms. If there was a pi here, then you can combine them, you can subtract them. This doesn't have a pi, this has a pi, you cannot combine them like that. So be careful. This is your answer. I know you're used to seeing just numbers and that's it, or numbers with a variable. This is fine, this is correct. And leave it in terms of pi. Don't try to convert this to 3.14 and get an answer unless I ask you for it. Other times, majority of times, leave it in pi. All right, let's go on to the next one. We have two shapes. We have actually three shapes. We have the rectangle and we have the two little half circles. Those two half circles put together will give you a full circle. So I'm going to treat it as one shape. So the first one is a rectangle, which is base times height, or length times width. So that will give me 24 times 8. So that would be 24 times 8. That gives me the 192 square inch. And then for the the circle, since I'm going to add these two, I'm going to put 1 and 2. So the circle, which is 1 and 2 put together. So it'll be pi r squared. The radius, that's half. It's not 8, that's a diameter. So half of that is going to be 4. So be careful, because you might want to quickly just put 8 and not realizing that this is the diameter and doesn't represent the radius. You got to be careful, precise, and work slow. Don't speed it up and make silly mistakes. So now we're trying to find this area. So we need to pull these two out so we can be left with the cyan color shape. So that means I'm going to put area of the shaded region is equal to the bigger, which is the rectangle, minus the smaller. And I'll put this in parentheses because it's together, and it's inches, square inch. That's our answer. Okay, next one. So this is a cuneiform shape, and it says if drawn, ABCD would be a square with a perimeter of 24. So we have that, and I'm going to connect them. So I'm going to connect this so I can have my square shape. And I'm going to put P equals 24. So this square is 24. And each side of ABCD would be the diameter. So this is the diameter of this half circle, this half circle, this half circle. So technically, if you got rid of this square, or just removed it, you would have this two half circle put together and create a circle. Same thing with this one. So you'd have two circles. So what I'm going to do, have 1, 2, 3, 4, and then I have this shape. This is 5. So I actually technically, literally you have 5 shapes, but if you were to combine, you have 3 shapes together. So they want you to find the area of the irregular figure. So I'm going to do the area of the square first. But do we know the side? I think we do. We can find it. If the perimeter is 24, and this, so that means P, and there was 4 sides, we divide 4 into 24 because there's 4 equal sides. So then that means each side is 6. So then it'd be 6 squared, gives us 36. So we found one of them. Now the circles, I'm putting the 2 half circles together. Why waste your time doing the area for each half circle when you could put the 2 halves together to make one? So the circle, it's 2 and 4 that I put together. It'll be pi r squared. We know the side of the square is 6. Half of that is 3. So we have 3 squared. That'll be 9 pi. And then this will be the same too. So I'm just going to do it anyway, because it will be the same. Alright, so now we're finding the total area. So the total area will be 36 plus, and I'm going to do 2 times 9 pi because it's the same. And then it'll be 36 plus 18 pi. We're not combining. And then there's no units, so we just call it unit square. And I'll put this in parentheses, and that's our answer. Actually, I'm going to box that. That's our answer. That's how you do that. So basically, it's everything that you already learned. You're just applying it and trying to find ways to efficiently solve the problem. Alright, so now this one, we're just combining the shapes and trying to find the total area. I'm going to use, so this is in purple. So this part, the triangle is A, and then the rectangle is B. So for A, since it's a triangle, it's half base times height. So half the base of the triangle, this is the same, the top, so this would be 27. And the height is not 40. 40 represents the height from the top of the triangle to the base of this rectangle. They gave us the height for the rectangle, so now you need to subtract. So for the height of the triangle, that would be 40 minus 8, which gives us 32. So then that height is 32. Be careful. Don't just throw numbers left and right and not knowing where they're coming from and thinking that you're going to get the right answer. No. So 0.5 times 27 times 32 gives you 432. Since there's no units to that, so we just call unit square. That's a 32. Let me just fix that up so that way when you look at it, you're not like, oh my god, it looks like an 8 or some kind of weird number. It's 32. Alright, so I got the triangle. Now I'm going to get the height of the rectangle, and that's, which I labeled B. And that's, again, it can be length times width or base times height, whichever. In this case, let me just put length times width. And then the length is 27 times 8. So that gives me 216 units square, or square units. So now you're going to add the total. So you're going to have 432 plus 216, and then you should get 648 square units. All right. Next one. This is more involved. We have a circle and we have a rectangle. You might think, oh, 2 triangles, but look at the overall shape. It's a rectangle. They gave you the measurement. This one is 6. AB is 6. BC is 8. and AC is 10. Alright, so they want you to find the shaded region of the figure. Alright, so now, since we have two shapes, I'm going to start off with purple. Let me extend this page. Purple one for the circle. So C for circle. I got pi r squared. Do we know the radius? Yes, we can find it. This is the diameter, 10. Half of that is 5. So it'll be 5 squared, be 25 pi. Alright, now I'm going to find the area of the rectangle and label that R, length times width. So L, W. So the length, we have the length, which is 8. And then we have the width, which is 6. And that's going to give us 48. Alright, so now we need to find the shaded area. Use green. So area, SR, shaded region. We do the bigger, which is the circle. And then we subtract the area of the rectangle, which is 48. And that's it. And then you just put unit, square unit. That's the area. Alright. Just make sure that everything, yep, that's all good. And I'll just box that because that's our answer. Okay, next one. I say anytime you're confused, you got lost somewhere, you don't understand, always go back. You can also email me to get more examples and clarification. Alright, this is another complex one. Well, this is a little tricky one. So we'll go through this slow. So we have AB, BC, and ED are diameters of the circle, half circles. So we got this. So ABCDE is a rectangle where AE equals 2 of ED, 2 EDs, and AB equals BC, which equals 4. Sounds like a lot of things going on. So let's just take it one step at a time. So they're saying that this is the diameters for each of the semicircles. Okay, this is a rectangle. All right, so now AE is equal, this whole side is equal to 2 of ED. We need to know what ED is. We don't know what it is. So let's look at the next thing that they gave us. AB is equal to BC, and they both equal 4. So that means this is 4, and this is 4. The whole thing is not 4. They would say AC equals 4. But this piece is 4, this piece is 4, so the total together is 8. So that means ED is 8. So I'm going to put ED is equal to 8. So if ED equals to 8 and AE is twice as much as ED, then that means AE is equal to 2 times ED, which equals 16. So then this is 16. All right. I think we got everything that we need. So now we can try to find the area of the shaded region. I'm going to start off with blue. So we're going to do the rectangle. Label it R. So that's length times width. So we got the length, which is 16, and the width is 8. So when you multiply those two, you will get 128. Now let's do this one. They both have the same diameter, so this is going to be put together to make a circle. So I'm going to put what can I put? 1, 2. So the area of the circle, that's a combination of 1 and 2, the two half circles, pi r squared. We have the diameter is 4, half of that is 2. So that'll give us 4 pi. Okay, we're done with that shape. Now we have this shape. So that's a half circle. I'm going to put C for circle. No, it's half, but it's 3. Half circle. So it's pi r squared divided by 2, because it's a semicircle. If you didn't have that, then you tell me that this is a full circle, and it's not. So then you put the information that you have. The diameter, the diameter is 8. Half of that is 4. So that would be pi 4 squared over 2. Simplify. And then that will be 8 pi. All right. Now we need to use green. We need to find the area of the shaded region. So SR for shaded region. We take the bigger one, which was the rectangle, was 128. And then we subtract the smaller pieces. We subtract the 8 pi, this piece, and we subtract these 2 little pieces, which we put together to make a circle, which is 4 pi. Combine like terms. So this will become negative 12 pi. And we've got our area for the shaded region, the green one. And I'll put square unit, since we don't have any specific unit. All right. Next one. We have concentric circles. So this means 2 or more circles sharing a point on that circle. And they gave us information, so we're going to use that. We use red. Circle O, this is this circle, and circle B. This is the middle of the circle. That represents the bigger circle. The smaller one, circle O. AB and AC are diameters. So AB is the diameter of the small circle, AC the big circle. They say that AB equals BC. So this portion equals this portion. And then they say that OA is equal to 3. So from here to here is 3. So this is the half of the circle, then that means the other part is 3. So together, it's 6. So if I can try to show that. So this part is equal to 6. So if they tell me that AB, which is 6, is equal to BC, then that means this is also 6. So that means the whole diameter of this circle is 12. So now, there was no shaded part, so I'm going to do the shaded part, which I think it did not show up. Actually, maybe I'll highlight it. So we want to find the area, the shaded area of the one that I'm shaded. Alright, so we're going to find the shaded area. Now let's start with green. We're going to find the area of the bigger circle. So I'm going to put CB. I should have put BC, but whatever. The big circle. And then we know that the area is pi r squared. We got pi. Radius of this bigger circle is 6. So then this will be 36 pi. Now the area of the smaller circle, so that's S for small, pi r squared. The radius is 3. That'll be 9 pi. Now we need to find the area of the shaded region, the yellow part. So we subtract the smaller ones from the bigger ones. So 36 pi minus 9 pi. Since they both have pi, we can combine them. So when you subtract them, you will get 27 pi. And I'll put unit square. And that's our answer for that shaded area. Okay, let's move on to the next one. They give us a radius. You know This part is also 4. So that means this whole part is 8. That means this also is going to be 8 too. So I'm just labeling all information based on what I know. So now I need to find the area of the square, which is s squared, and then 8 is 64. And then the area of the circle, pi r squared, the radius is 4, to be 16 pi. And the shaded region, because if we see something shaded, we know that we're looking for shaded and we're subtracting. So bigger minus the smaller. And then since we cannot combine them, unit square. And then I box the answer. Great. Next one. This is a little bit involved, but we can do it. So they're saying AB equals BO, OC, and CD. And AD, their whole diameter is 12. So 1, 2, 3, 4. 4. You got 4 little pieces. They're all the same. You divide it. 12 divided by 3 gives you 4. So therefore, this is 4, this is 4, this is 4, that's 4. So I'm going to put 4, 4, 4, 4. Now we can start doing the fun part. Finding the shaded area or shaded region. So we're going to look at the big circle, CB, pi r squared. The diameter is 12, so half of that is 6. So it will be 6 squared, and then it'll be 36 pi. And then the area of the smaller circle. So we're looking at this, the white part, the white circle. The diameter is 8. Half of that is 4. That's the radius. So that would be 16 pi. Now we're going to find the area of the shaded region. I'm going to use blue for that. Or shaded areas, shaded region. The bigger minus smaller, the bigger circle minus the smaller circle. You can combine them. So that'll give you 20 pi square units. The next one, we're looking for the total area. So we got 2 shapes. So we got the triangle, and then we have the half circle. So for the triangle, AT, half base times height, we have the base, which is 4, and then the height, which is 6. And then if you do 24, and half of 24 is 12. And 12 square centimeters. For this half circle, so let's put area, I'm going to put half C, this half circle. Pi r squared over 2, half of 4, that's the diameter, half of it is 2. And then simplify some more. And then that's centimeters square. Then you add them together because we're looking for the total area. There's nothing shaded. So it'd be 12 plus 2 pi. You cannot combine them. They're not like terms. And then you just put your unit. All right, on to the last one. Actually, it's the same thing. If you were able to get this one, then you could do this one. So we're looking for the total. We're doing the area of the triangle, which is half base times height, half 6 times 7, and then 42 divided by 2, and then the area of that is 21. And then for the semicircle, half circle, is not base, pi r squared over 2. Half of 6 is 3 for the radius. 9 pi over 2. You could put 4.5 pi if you want to turn it into a decimal. And the total for that is 21 plus 4.5 pi. Can't combine it, so leave it as is, and it's centimeters square. Square centimeters. And that's our answer for the total. All right, there was a lot to digest. Based on, since this is part 2, we learned about, from part 1, we learned about the different types of formulas for areas of each shape. Actually, if I can go, I can go back. Yeah. So we learned about the formula. So basically, you just have to learn them. Some of them you already know. Rectangles and square, you should know them. And triangles. Other ones, just know. A trapezoid would be one that's tricky. Just know them. And know that perimeter is meaning you add all the sides. Area is based on these formula. And there was a question that was that's here where it says circles are not polygons. Why not? The reason is they don't have sides, so they're not a polygon. Polygons usually, like, you have your shape, no curves. Actually, I should just say no curves. Circles have curves, they're not a polygon. So we learned about the area, we learned about the perimeter. Perimeter, especially with trapezoids and triangles, you add the outside, not the height. I don't want to see you adding the height when it comes to perimeter. Same thing here, it's the outside portion. And pay attention to what they give you. If you don't have the radius, you can find it by dividing it by 2, the diameter by 2. If they ask you to give both, the perimeter and area, give both. Don't give one or the other. Do not mix up circles, area of circles, and perimeter of a circle. Perimeter of a circle is the circumference, which is 2 pi r or pi d, and area is pi r squared. So yeah, and then when it comes to adding a weird shape, find the total area, look at the shapes that you're familiar with, break it down into shapes that you know, find the area for each of them and add them all up. And when it comes to shaded regions, find the area of the 3 shapes that you see, and then subtract the smaller shapes from the bigger to give you the leftover area. Okay, like I said, there's a lot to digest. If there's any questions, feel free to email me and I can always help you out. All right, with that being said, this concludes our lesson, and see you around.